To take it easy on you, of course, to get into the afternoon, we're going to have this nice little panel discussion with David and Brendan that just Allison introduced. And these guys are active participants that have fantastic solutions that are in the graph space that I'm going to let them describe. And actually, we're going to start off by just having you guys introduce yourselves and describe what your awesome technology is. So, Brendan, what's your awesome technology? And who are you?
Okay.
Are you on?
I don't know. Well, my name is Brendan Madden. I'm the CEO of Tom Sawyer Software. We're a graph visualization and analysis company. We were founded in 1992. My background is I have degrees in physics and applied physics, and I worked in the data communications group at IBM Research for 5 years in college. So I worked on basically the network presentation consoles for NetView from 1985 to 89. It was all OS2 and Presentation Manager. So I built the automatic layout to draw the SNA and APPM networks, and then later I worked at Santa Teresa Laboratory in 80 Cycle, and I built another automatic layout system to draw a schema like ERDs, query results, impact analysis diagrams, and then started Tom Sawyer Software in '92. So that was we were graph layout experts. So we grew from graph layout into graph visualization, and then later into graph analysis. And over the years we've had C++, MFC, ActiveX, ASP.NET, Swing. Now in more recent years it's all web apps. So it's it's more like desktop, image map web, HTML5 web, front ends. So that's where we have several hundred commercial clients. The main markets, I guess, or I can maybe.
No, yeah, we can get into that later. That's great. Thank you.
Yeah, later.
David?
Yeah, I'm David Colebatch, co-founder of xnlogic. We're a Toronto-based graph services company. Founded just over 2 years ago. And the xnlogic story really came about because of Lightmesh, which is the product up on the screen here. We wanted to build a network configuration management tool for reasons I'll get into in a minute, but there was no application framework to do that. We had a graph database to store data, but no way of really representing the business model, permission structure, and those sorts of things. So xnlogic provides an application framework on top of Neo4j, which allows you to define that business model and produces a domain-specific RESTful API, which I'll show in a bit. I first cut my teeth writing network configuration management software in 2005 using legacy databases, if you can imagine what they are, and quickly hit the wall in terms of the types of depths of queries we could do when looking for related data. And so naturally, a graph database has fixed that problem, and so we've been on that since 2011.
So that's a good segue. So I wanted to ask, actually, so for both of you, you have technology that is obviously, works with graphs, that you do visualization, you work with networks that are graphs themselves. But can you talk, and this is one of my obligatory sort of fluffy questions. When did you have your own personal kind of graph epiphany? When did you realize that graphs are obviously the right way to look at these problems that your customers are trying to solve?
For me, it was the late 80s when I first started. I realized it was like case tools, object modelers. It was a different time, but I viewed it from, it was like graph data structures and then relational diagram representations, which needed graph data models to manage the diagramming or the connectivity and the elements and everything, the paths. So that's where it began, and
then it was just obvious from there where to go.
Sort of. And then it was like I realized multiple styles for multiple markets, that kind of thing. Yeah. Multiple drawing styles for multiple markets.
Yeah. For us, it was a pure performance thing. We hit the wall in terms of trying to find dependencies between IP addresses and applications and customers that depended on those applications. With a relational database system, it was just join after join after join, and it didn't scale very well. The types of data centers we manage with our software, thousands of servers within them, and our customers have more than one data center as well. And so the graph presented a really simple way to fix that problem. And it actually enables us to deliver this as a multi-tenant application now as well.
So I mean, with that, like, so you obviously the products themselves work with graphs, and you guys think in terms of graphs. Do you find that it helps for your actual end users to have, like, are they just stuck in their domain, or are they having their own realizations that, like, oh, well, obviously, like, all the stuff we're doing, it's all just one giant connected graph of stuff? Do you find that that's true, or?
Some people are very domain specific, but other people, particularly the architects, are thinking more generally, like, and how they model the data they have. Okay. They may be more graph focused than the end user software people. So we're seeing it at the architect level, where they think of graph data structures and attributes and properties. And
right.
Yeah, okay. Our end users are very domain specific. They really only think about their IT problems. How many change tickets do I have against this customer? Outstanding. Those types of things. They don't really understand that under the hood it's a graph. But certainly when they're interacting with the tool, they are traversing the data as they go through. And so it's flexible in that there's not a whole bunch of pre-canned reports that they have to run. They could start with an IP address, traverse out to interfaces and servers that are attached to that, and then come all the way back to that same IP address if they wanted to.
So it's not that they have to think in terms of graph, but it's more natural for them to think in their domain because you've got a graph.
Exactly. Yep.
Okay. So it's going to take a little bit of time to help people understand, like, what your technology actually does, to let you give a quick demo and, like, kind of walk through some stuff of what you've got.
Sure.
Yours is queued up here, David, if you want to go ahead and start.
Sure thing.
Here. And I'll take a moment to sit.
Okay, well, I just want to showcase a little bit of the search interface that we already talked about here. When I first log into Lightmesh, I'm presented with a list of different organizational groups that I might belong to, the service management group, solution design, build, and operations. And then on the right, I can see some of the data types that I can manage. So I can look at my business services or my applications and so on. Now, this is just some small sample data I had ready. So if I click on any one of these, it's going to dump me into a search. Is the mouse button? Okay, so it's a very search-centric app. I'm just going to zoom that out a little bit. Or maybe there we go. So as soon as I click on one of the data types, it dumps me into a search. It's completely RESTful. You can see that the URL is mapped to the data types to get there. And I'm just going to get rid of the menu. Now what we have on the left is some property filters or relationship filters that you can apply. So I can filter by name very quickly. And it's just going to do a quick little query to the server. I can also filter by parts. In this case, there's only two different parts. And that parts is sort of akin to the labels that were described for Neo 2.0. So we've implemented them as properties. As I select an application, or maybe all of them, I can then see some filters to the left, to the right, where you are. And so I might want to start filtering based on related data. So if I look at these applications, what systems that they run on, and then what network devices are a part of that system, I can then filter further and see what zones those servers are a part of, and I can go back. If I go back here, I wanted to show you something. I'm going to select on these servers here, and I'm going to use an example of filtering by parts or by labels. And so I select just cloud VMs. That's all I'm interested in. Stuff that's on a public or private cloud here. So there we go. I've just reduced that list down to cloud VMs, and now I can continue my traversal going forwards. So out of all those 5 cloud VMs, there's 2 zones that are impacted.
So this is like the network version of the Facebook graph search that Max was showing earlier, kind of, right?
Yeah.
Instead of typing natural language, though, you're just kind of traversing down, drilling into stuff.
I'm traversing down, yep, and I can filter by.
And it's already Neo 2.0 compatible, thanks to its label concepts. Yeah, cool. All right. Brendan, do you have something you want to try to show us? Yeah.
So, a lot of what we're interested in graph databases and NoSQL is around like exploration, neighborhoods, exploring and bringing data into the front end and then working with the data. So hopefully
So, and is your app, is it a desktop app or is it web-based?
So we have a design, we had visualization, layout, and analysis as SDK products. Now we have a line called Sawyer Perspectives, which is a design timed environment. So it's like design, preview, deploy. You design an app as an XML-based project, which manages the mappings from your data sources all the way through to your data model and your rule-driven graphics. So everything about the front end is defined. Almost everything about the front end can be defined at design time in a visual application.
So what are we looking at here?
Sorry, let me go ahead full screen. So we have. So you design an application once, you preview the app iteratively, and then you deploy. So you can deploy to Swing or Eclipse SWT for desktop, image map web apps, and HTML5 web apps. So then our software is typically embedded into a larger network topology system or a link analysis system or process management system. So I'll show you. Here is since this is a networking talk, this is an example of a project. We have a schema, some data sources, use graphical templates for the front end, and multiple views of data. So like network map, several network map views, several tree controls, several table views, some filters, and search front end representation. So if I preview that, here's a pre-made front end where we have a lot of synchronization between the view types. So we have built-in synchronization, all the viewing and editing tools that you'd expect in an app. Like marquee zoom, focal zoom, level of detail graphics, search for the routers in the network. So it's all synchronized. You can then do like filters at the front end, like for instance display settings. Let's group by location. You get a dynamic view generation. So we're doing a lot of the link generation from the attributes in the data model. Like so you're applying filters dynamically, so that's an app as HTML5. Same application now as a desktop app. Same design, automatic layout, like orthogonal view, hierarchical view, like a circular view, and it's all. So the idea is the same application can deploy like to mobile by the end of the year, and then we have. So it's like visualization. Then we have graph analysis technology like pathfinding, clustering, centrality measures, various social network analysis, reachability, impact analysis.
So talk about that a little bit. So like those are the two tools. How are customers actually using this part primarily to do the work that they need to do to manage the network? I mean, is it mostly analysis, like doing failure analysis, or?
So a lot of the apps are. Well, we have storage customers. There's CMDB customers. There's like classic, drawing layer 2, layer 3 stuff. There's MPLS applications. There's a lot of.
You can name names if you want to.
Yeah, there's new like application performance management companies like Optier is a new customer. So we sell to like Tivoli, BMC Atrium, HP's BAC, Riverbed, Cisco's.
Lightning? Not yet.
No, Lightning.
Yeah.
Like several Cisco applications use us. CA's Wiley and things like that.
And what are they predominantly doing with the software? The main activities.
Yeah. So some are network monitoring.
Okay.
Some like Telenor or CenturyLink are like inventory.
Mm-hmm.
Inventory and fault and service management apps. So sometimes it's like, or sometimes it's enterprise architecture, like BT or someone like that is like really interested. They have all these enterprise silos. So sometimes it's they're trying to understand the enterprise architecture they have, like all their systems, the storage, for change management, probably, to manage change processes.
Right.
Exactly the same as that.
And so, Dave, is it the same? Like, so you guys have a very different approach to the same kind of problem domain, though, right? Like, like, so describe, like, so what's so different about like how you go about it, David?
Our approach is different, and it's more a design time tool, whereas a lot of tools out there show you just what you've got running in your IT space today. We like that as well. We use that as an audit source, so we integrate with things like Tivoli, and we integrate with Atrium from BMC. But where we differ is that we mainly interface with the solution designers within an IT organization. So they'll come to Lightmesh and start gathering their customer requirements for a given system. They'll start creating the solution design all within Lightmesh. And we automate a lot of the workflow that goes with that design process. So we automate allocating IP addresses and switch ports, cabinet space, or what virtual cloud you're going to spin up a VM on. We take all that out of the design time work.
Yeah, I think the graph databases are interesting for query, like neighborhoods, where, you figure if you have to retrieve, like if you want to run analysis, like show me the neighborhood around this node, like maybe for some monitoring purpose, and you have to, for instance, find the node, then you have to do some reachability around the node, and like doing it with SQL or like some other data model, they're always iterating the full network, to try to say what's so there's no real natural connectivity model in like a SQL store, right. Or you have to do expensive queries compared to just reaching the neighborhood and things. So a lot of times, this is what's.
The impact assessments are a very real one. You have a customer who says, I want to do some maintenance on this line card and a switch, just that one line card. Well, we can actually model out all the connected cables to those switch ports, what servers they're plugged into, the VMs on those servers, and the applications, and so on. And so at the end of the day, when an engineer says, what's the impact of this line card, he gets a list of customers and who's going to be calling him when their stuff breaks.
Right.
So it's a really
which is critical. It's always critical.
I think so.
Yeah. Sure. Yeah. Okay. And so what is the integration actually for both your tools with Neo4j? Like you're actually sort of directly based on Neo4j, right, David?
We're embedded. So we use, my co-founders developed a Pacer gem called Pacer.
What's Pacer?
Pacer is a graph traversal library written in Ruby. So it runs in JRuby, uses Neo4j embedded, and allows for some really expressive query types and the ability to actually build your domain model right there in the library, so you can extend Pacer itself. And so we build on top of that, and then on top of that is the xnlogic framework. And that's the one I spoke about earlier, where you can define your business domain and drop it into the framework and get a domain-specific RESTful API. And that search interface I demoed before, that was all dynamically generated based on that metadata coming out of the RESTful API. So as we add technologies to the stack, like we support cloud VMs now, maybe we support VMs that are on Eucalyptus as well as Amazon, well, they'll just appear automatically in the interface, no code changes required.
Yeah, in recent, I didn't even know about Neo until 2011. Then, so late 2011, and since then,
Welcome.
Yes, because I'm not aware. Since then, I've seen about 10 commercial projects where they're binding Neo and Tom Sawyer together. So there's definitely one cloud project. There's a supply chain project. There's an network inventory project. I've seen.
So what does that look like? Are they creating the data in Neo4j and then interfacing, or like what's the?
So to be honest, I don't know if Neo is the only data source in the app. I think.
Not yet.
Not yet. Yeah, I think there may be SQL, and then they're building new functions where the SQL model, the NoSQL model, the graph model is more natural. But usually they have a legacy. The successful apps always have a history. So that's, and nobody knew about NoSQL before, but now they're maybe doing there's a pathing app, or they're doing some service management app, and then the graph database gets more natural. So sometimes they have a legacy and they want to get rid of it, but they have to migrate. They can't just throw away what they have. So they start adding a new source, and they start storing stuff. So cloud and data center stuff, I know one project where they have a very large Neo store for I don't know that much about data center. I should be panelist, but there's a large Neo store attribute. I think I'm not sure if they're using. It's probably a little older than the Cipher interface, but they probably the Java API level they're using your product.
Mm-hmm.
Yeah. So.
I'm gonna ask, are we gonna stand up? Should I be standing up?
Yeah, if you'd like to. I don't know why I ended up standing.
No. Just
Yeah,
you guys are talking behind me.
Sorry.
There we go. That's better.
So actually, now that you're talking about customers, so pick your favorite customer and like describe their end-to-end sort of use case.
All right. My favorite customer is actually not the target customer we have. Our targets were big enterprise data centers. But our favorite customer is actually a mining company, a gold company, and they have sites all over the world. And so we were always targeting the complexity inside big enterprise data centers. Their complexity comes from having lots of small networks in tiny little mines all over the place. And so their kind of use case is much different. But yeah, they're probably my favorite customer.
Yeah, I guess I'm seeing the most NoSQL interest in sort of in the link analysis and network topology space, where link analysis is like networks, but on many more entity types, many more attribute types, more than you see in the network. So they're like the same thing, same technical app almost, but maybe on different scales. My favorite, well, networking, to be honest, we did that for so many years, it sort of got boring, so that's why we start to get more excited about real graph, the real explosion of the graph, like you see in search or you see in fraud and link analysis and, problems in, like medical fraud or something. You see there's a lot of entity types, and so graphs are a much more natural model. Like we've had a few lately in social services where it's they're actually pulling up the family network. Like this guy is involved in 3 different child cases. So it's really a much more natural NoSQL model. Like this person. So you're trying to place a kid who's been abused and so they're calling up basically the reachability network maybe 5 or 10 hops away in order to place the kid in a foster home properly. And then they have to manage him in a regulatory manner till he's 18 basically. So there's a lot of, those are large scale kind of public government apps or something, but that's really interesting. So that's, I think, a real natural kind of NoSQL one, like social services.
Yeah. That's interesting.
Yeah.
I mean, where do you see a lot of growth happening?
Cloud adoption.
Oh,
so
really?
A lot of our customers, they run their legacy data centers. They come into us to say, hey, we don't know what we've got, but we want to migrate to the cloud. And so they're coming on board and when using our API to push data into Lightmesh, or into Neo, and then planning out their migrations into AWS or Rackspace from there. So that's driving a lot of work.
Right.
Yeah.
Do you see a lot of interest in cloud as well? And
yeah.
You have.
Well, it's there's definitely a lot of interest in the management of cloud infrastructures, management of data. So we see more of the demand there, like in monitoring environments for so that's where we don't see that many. Most of the customers we see are more enterprise apps more than SaaS apps. So in that sense, they're maybe behind their own. Maybe it's private cloud, that kind of thing. But there's a lot of large scale. There's a lot of all these management, these semantic types. They have a lot of layers in the storage, and they're doing like whatever, trying to do performance management across, keep apps up or something. There's a lot of value there. Like they're selling into like banking, try to keep banking systems up, or
right.
So those are the kinds of people that need the good operations system, and then so how are they managed? And some of them are SQL, some of them are like memory models, just maybe some homemade data model in memory, and they may not have gone NoSQL yet.
Okay.
So it's sort of like an API model in memory that might be home built, and some of them are probably good candidates if you could reach to find them. Yeah. That's it.
Well, so let me ask you both. Actually, this is sort of product developers. For some of the things I introduced in Neo4j, like that we're starting to do with 2.0, some of the new ideas coming along there. if you had a wish list, like what's missing in Neo4j right now that would make it easier to use for the applications you're developing now? And how does the stuff that I presented fit in?
Ooh. I think my wish list is actually on your GitHub issues page.
Nice.
We have a back and forth on that.
Good, yeah.
It's the configurable ID management and stuff like that.
Oh, interesting.
It's really interesting. Better index control, I think. When we install Neo4j, we sort of expect indexes to work. And right now, it's a little bit of a kludge, but it sounds like the future is very bright for index support.
Yeah, it's definitely what labels are targeting, is making that experience much better.
I think we're well positioned to take advantage of that.
Cool.
So it'll be good.
We're building like we have done integrations at the API and the REST API level, so far, and so we're interested in building like a native integrator. We call them integrators, which is through the Cypher interface, and so I'm interested in the data sets are growing fast, so. For us, it's we don't want to be in the graph, so when these data sets really grow large, and then you start getting into exploration applications, so we want to have maybe a closer connection where we can modify our data model to benefit your graph model.
Right.
So, because we kind of go from graphs to like a flat model to views, we should say graph. So to make the query better, so sort of applications like this. So,
would it be helpful at all? Like, so you have a very strong visualization component in your application right now, and you have like sort of this drill down thing. I think you also showed me earlier. We didn't get a chance to show it, like a tree map kind of view. Do you think there's value in Neo4j having more visualization itself out of the box, or is like our baseline visualization good to get going? And then really it's the application's responsibility to go from there.
For us, the data browser is fine for just discovering through serendipity like what's going on in the data.
Yeah.
We also use the REPL. We're also using Pacer in Gerb all the time to discover data. So adding more generic visualization wouldn't help us. I think we add value by providing context around the data to our customers.
Yeah.
So that's a no from us.
Right, yeah, that makes sense.
Yeah, I mean we're interested in like good partner accounts, like where we work together. Or, I think there's a lot that can be done, and because we're like a natural graph company, like sort of like you are. So maybe there's some nice.
Well, I'm almost curious about, like, you have very styled graphs, right? And one of the things that people like about the data browser is that you can, if you have things that are labeled as people, for instance, they can show up as little people icons and do cute little things like that. And you have some of that in your app as well. And it seems like from an operational perspective, it'd be nice sometimes to be able to have a similar view. Like when you're in the full application, great, of course you've got a more rich view of the data. But when you see if you drill down to just using Neo4j, if you're debugging the data set, it'd be nice for that to look somewhat like what the application sees as well. And I don't know how we would go about doing, like, sharing styling, information, or if that ends up being just keyed off of labels. Labels might be the way really out of that, right?
A lot. Yep. Some CSS tied to labels.
Yeah.
Cool.
Yeah, I think life sciences would be interesting as well, but modeling and pathway apps and things. But it's hard to, you might be very good there because there's a lot of open source in life science.
Right.
So your model might be natural in the, somehow getting grant money. It's not easy financially because. But I think open source might work well in a lot of the life science apps that are also open source. But yeah, I know you're interested in commercializing everything, but I think you could get them to.
It's always a balance.
Yeah, like protein applications, gene applications, pathway applications.
So does anybody in the audience have any questions about like the use cases, about like how these products are being used, how they're taking advantage of the graphs, or anything at all you'd like to ask about? Go ahead.
So it's a little bit of a off topic, but it's visualization. So in life sciences, one of the problems is the networks look like hairballs. So visualization of a hairball is like a big problem. So we're very visual, but how do you show the parts of the hairball that are relevant without showing the other?
So that. There's a question about, like, when you're visualizing a graph with a lot of data that's very connected, when you actually see all that data, it just looks like a hairball is the description. So like, how do you guys handle that?
Well, this is the whole big data problem. So people need patterns that. So we're interested in like applying analysis to the data and building patterns. So for instance, you have a large data set. You maybe run a reachability on some subset of it. So we'd select a piece of it, then maybe run some centrality on. So it's sort of like chaining, sort of like Yahoo pipes, right? To keep or maybe you run a clustering. You collapse everything. So clustering is like we have like high-speed clustering, so you can define the cluster as like you might have many clusters in this large graph, and so you show up an abstracted high-level view, and then then you can do filters and stuff by the cluster number, or show the members of the cluster, or so there's a lot of so this problem of going from a lot of data to just what you want that's like the holy thing, right? Holy grail.
Yeah, that makes sense. Any questions about like doing network management with graphs? Anybody out there trying to do this stuff on your own? Nobody yet? Okay. Any other questions? Go ahead.
Just sort of like a small thing. What clustering algorithm is that using? That's really pretty.
Oh, this is our symmetric layout by default. So it's a high-speed subquadratic automatic layout. So it has, for example,
I
here.
recognized it.
Well, define high speed. Like what complexity?
So it's like n root n log n, something that's subquadratic. Yeah. So we do things like over here, like filtering. So filter the data set. So I shrunk it down. Then maybe run the layout again or something. So you see it's synchronized, like the centrality results from the other page are showing up here as well. So it's or orthogonal is like it's an overlap-free schematic representation where the labels are guaranteed to be overlap-free. You see. So it's and we have clipping to the image representations and things like this. So it's clipping to the. So there's a lot of technology and many years of work.
Have you considered using OpenWorld? It's a linear clustering thing that basically is a Freshman-Reingold with the sort of like cutting coefficient. So if you have any links in the Freshman-Reingold algorithm that basically get beyond a certain length, you just cut them and you get very strong clustering. That it seems to be what you're trying to do with the other things, but it's got a linear complexity.
Yeah, no. We have.
Yeah, I don't know that I heard it. So, here, can we give him a mic? Does that mic work? I'm not going to be able to reiterate that question. Something about math.
So the question was, is this working? I can't actually.
It is, yeah.
Okay,
You're
wonderful. Right, so the question was that for a lot of these sort of clustering representations that they're looking at, the subquadratic is very nice for complexity, but when you're looking for, a very large data set, it's possible that even being subquadratic isn't going to be a low enough complexity. And there's an algorithm out there called OpenWord that's getting sort of a lot of attention. It's a plugin for GPhi or Gephi, however you say it, which is the big visualization thing. And basically, I was just wondering if you had ever considered using that to get sort of a linear representation of very strong clustering. And then there were more math things involved, but probably not worth talking about.
Yeah, we have like we have something that's like a high. It's not ratio. It's not multi-way ratio cut. It's something different, but it's.
I'm going to take it back.
So yeah, we have I think a good clustering representation. Yeah, I know Fruchterman-Reingold as a layout technique is obsolete. I'd say that's old. But
I mean, it's very pretty.
Yeah, it's just it's not that fast.
Yes.
Right. So there was a lot of innovation in the last 10 years in that. So things used to be cubic. I believe that's cubic in layout speed. So it's kind of limited to say 500 nodes or something like that.
How many people, just as a show of hands, how many people are trying to do their own graph visualizations today? I assume you are. Yeah? A couple people, a little bit in the room? Okay. There was another question in the back of the room. Who was it? It was you. Yeah.
For Brendan,
Yeah. Good.
so you had been working with Graphic, or with Graph on the top level of modeling for quite a number of years. And with the Graph database, how did that change anything from your point of view?
Yeah, we were, we're kind of coming at it from the other side. We were visualization, layout, analysis, and then we've been moving back from the front ends back to the data model, and then back to the store. And I think, I think the big advantage is going to be in exploration. As you move, what's happening is a lot of people they only want to show a subset of the data. Sort of remember, I don't remember like the insight hyperbolic tree kind of stuff in the old days. You would navigate across an information space and you've got to load and unload. You've got to like retrieve the neighbors. So a lot of people, this is really interesting, like exploration environments, but the data, but people are wanting us to like load, and they're actually binding these things to live apps and things, and so the retrieval of the data, you need the incident edges to the nodes to be able to do like fast and retrieve the neighborhoods and things like that. So that's where I think it's kind of step ahead of like SQL or
Because that's what we do really, really well.
yeah. So that's what. So it's we had model and integration architecture before we knew about Neo. So we're building like a strong connection to it, like a native connection. That's kind of our. So it's yeah.
So you would say retrieving neighborhoods was one of the
major there's like in like link analysis, social network analysis, you're often trying to find paths, clusters, even assessing like root cause analysis. You really need you need either a directed graph or an undirected graph model, or you need like sometimes the links have direction and sometimes they don't. So you definitely need algorithms. So for years we had analysis, but nobody knew how to go from what we called analysis to the domain. Like, except maybe for the most simple, like path finding, shortest paths, So there was a big gap between what we could do and what the market kind of understood, except so they didn't know, but I think it's changed with, the LinkedIn, the recommendation engines, the social graphs, all these geo search, and so all that's like attributed graph-based, Twitters and all these things. They're really graph models are really the most natural probably way to do it. Like, and they just and then the scaling of those apps, because their data, so I think things like with Google or all the graph, probably the graph stores are probably the best. I don't know, I may not know enough to know if it's really the best, but
It is. It is. Yeah, Alison.
A segue to that question. When people come to you guys, do they already know that they need a graph database, or are they just looking at like how? When I talk to a lot of people, they automatically like, I needed a graph database, so I went with Neo4j. But I'm wondering, like, what kind of problems do they come with to you that you guys know our graph database?
On the light mesh side, they're coming to us with data center problems and information problems. So no, they just come with those, and we tell them you need our product with a graph database. But on the xnlogic side, when we're doing consulting around graphs, oftentimes people already have made that jump. They realize they've got a lot of connected data. Maybe they're using a document store now, and it's not very good at querying relationships. So they're like, hey, how do I get this into a graph? And sometimes the solution is to use a graph and a document store and hydrate from there. But yeah, we take each case as it comes.
Cool. Any other questions from the audience? Anyone? The
Timer's run out.
The beep says the timer has run out. Yeah, so we're good as well. Okay. Thank you all for listening. If you guys have any closing remarks, no? Thanks for your time as well.
Thank you for inviting us to talk.
Sure. Cheers.
Thanks.